All right, so the way my camera is positioned today, I'm actually going to turn this so that I can see, some of the comments because I'm looking at it at an angle. So I'm going to go ahead and turn my screen a little bit so that you guys can actually see me, um, see what I'm doing here. So let me go ahead and change up a little bit for what we're going to kind of go through today. Okay, and let's see here. Okay, so let me switch over here. There we go. So for those of you all that came in the building, you may have seen me kind of go through and have this up on the screen, and it's the oxidation numbers or oxidation rules for assigning the oxidation numbers. So this is what we're going to kind of cover today. And in order to understand electrochemistry, you've got to understand oxidation rules, okay? So what I have on the screen is, and let me make sure that it is uh, that we are on this. So I don't see it. Hold on, y'all. Right, so let me make sure. Okay, yeah, there we go. Yep. Okay, we're good now. I had to make sure. Have to make sure. Okay, so the rules with oxidation numbers, um, you're going to have to know a couple of things in order to figure out how oxidation rules work. So the general rule for assigning oxidation numbers are as following, okay? The oxidation number of pure elements is 0. So if you are doing oxidation numbers and you're trying to figure out how do I assign them, you got to remember this rule right here. Pure elements such as oxygen, nitrogen, phosphorus, sulfur, sodium, iron, etc., those oxidation numbers are 0. And that is if they are in its purest form and they're not combining with other elements. So if you see O2 by itself, if you see nitrogen by itself, if you see any element that's by itself and it's not combined with other elements, then you're going to say it's 0. The oxidation number of a monatomic ion is equal to its charge. So for instance, if you have sodium with a +1 charge, then sodium has an oxidation number of +1. Chlorine has an oxidation number of -1. Okay, those are things you want to keep in mind when it comes to your oxidation numbers. Another rule is that oxidation in compounds usually has an oxidation number of -2. So if you have a formula like peroxide, H2O2, okay, then in this particular case, oxygen would have a oxidation number of -2, okay? Except in this particular example here, where it would be -1. So if you have H2O2, you would assign the oxidation number to oxygen as -1, okay? And in compounds with fluorine, where it can be positive. And I know a lot of times students get these rules mixed up, but if you have these rules near you when you're doing your homework, it makes life so much easier. Hello, Sweet Turkey Barbecue. Look, it's lunchtime chemistry with Professor TK the chemist, and we got Sweet Turkey Barbecue coming in the building, making me hungry. But I'm fasting from meat, so I can't eat any meat right now. Hello, Shahad. Yes, fluorine is the most electronegative element. So yes, to answer your question. Yes, yes, yes. Fluorine is more electronegative. Yes, that is correct. Hello, Catherine. So now, hydrogen typically has an oxidation number of +1, except when bonded to metals and binary metal hydrides. So in other words, if you're bonding sodium, like for instance, sodium has a +1 charge, hydrogen has a +1 charge. But if you're combining those two together, okay, hydrogen will have a -1 in this particular example, okay? Again, hydrogen typically has an oxidation number of +1, except when it's bonding to metals. So, but if it's bonding to, let's say, chlorine, then no, because chlorine is a nonmetal. But if it binds with metals, like pretty much anything in groups 1 through, pretty much like groups 1, 2 through 12 and 13, that's what we're talking about right here. Fluorine compounds always has an oxidation number of -1. And as Shohag had kind of brought up a second ago, as the most electronegative element, fluorine always attracts electrons in chemical compounds. So with fluorine, it's going to have an oxidation number of -1. Now, when you talk about the sum of oxidation numbers in a neutral compound, it's going to be equal to 0. So if you're writing out a formula, like let's say NaCl, for instance, if you're looking for the oxidation number for one of those elements, whether it's sodium or chlorine, you're going to set that compound to equal to 0. If you have polyatomic ions, it's equal to the charge. And again, we're going to do examples of all of these things that we're talking about. So let's say that you are trying to find the oxidation number, let's say oxygen, okay? You're going to say, you know the oxidation number for sulfur, you're trying to find oxygen, you're going to set the formula to equal to that -2 charge. Thank you, Trina. And again, as we restate this again, alkali metals, again, those that are in group 1, they always have an oxidation number of +1 in their compounds. Some examples are like sodium, potassium, rubidium, okay? Those elements that are in group 1, lithium. Those elements that are in group 2 always have an oxidation number of +2 in their compounds, okay? So examples include like magnesium and calcium. Knock it out the box, Trina. You got this, girl. You got this. Have faith. And remember, if you don't understand a question, move on and just come back to it. Put a star beside that question and come back to it. Okay? But don't panic during your test. Answer everything that you know, but don't leave any money, aka points, on your test. Answer everything that you can, even if you have to guess. Some points is better than no points. And the next rule, you're welcome. You are so welcome. Halogen elements, those that are in group 17, usually have an oxidation number of -1. Now, of course, there are some exceptions to the rules, and those exceptions occur when there are more positive in compounds with oxygen or other halogens that are less electronegative. Yes, I do, Tristan. Yes, I do. I tutor college students and high school students. Yes. And some final tips to remember, someone brought this up a second ago. Oxidation is loss and reduction is gaining. Oil rigs. And then another point that I want you guys to remember here as well, and I'm going to zoom in so you all can see this, okay? Hello, Giselle, what's going on? Is this rule right here. Remembering that electronegativity increases across a period and it decreases down a group can help you also predict whether an element in a compound will have a positive or negative oxidation number. Now, we're going to keep that in mind because there are some exceptions even to that rule. And if you know what electronegativity is, that also helps you as well. Are you serious, Giselle? Well, here's the thing, though. From what I gathered, it's going to take, they say, years in order for that to actually pass for this band. But let me tell you, there are too many people on this platform that are doing positive things that they're not going to let that happen. At least I would hope not. At least I would hope not. As a matter of fact, there are too many people on this platform making hundreds of thousands, if not millions of dollars, just doing those ads and sponsored ads and selling things. So I don't know. I don't know if that's gonna go all the way through. Now, if we look at this, yes, that is correct, Shohab. That is correct. That is correct. So let's take a look at some of these. Yes. Yes, I agree with that. It's going to take more time. Yes. If you take a look at assigning oxidation numbers, okay, if you go by the rules that we discussed a second ago, then you should be able to get these answers right here. So we'll do a couple of these problems and let's see what we get as our answers. So if we want to assign the oxidation numbers to all the elements, okay, what would the oxidation number be for, let's say, hydrogen and oxygen? Well, I know that hydrogen has a +1 charge and oxygen has a -2 charge, okay, because of where it's located on the periodic table. Again, if we go back to those rules will help. Okay, thank you, Loco. Very good, very good. Thank you, Sasha. Thank you, Elle. Take a look at the next one, sodium and chlorine. Most of the time also, guys, most of the time, the oxidation numbers are also assigned based on their location on the periodic table, as we said as well. Thank you, Giselle. Thank you, Christian. So if we look at sodium, I know that sodium has a +1 charge and chlorine has a -1 charge, okay? So when you talk about assigning oxidation numbers to these elements, all you have to do is know where they're located. And if you need referrals back to your chart, then you can do that too, okay? You can always refer back to your chart. Okay, you said it's the H2, make it neutral. Hey, Philip. So for that one, yes. So if we were to assign, yes, that is correct. Because if you say 2, that subscript of 2 times that +1 minus 2, yes, you're going to end up with 0, which makes it neutral. That is correct. So again, these are just some of the examples of trying to figure out and establishing the oxidation numbers, okay? Now, let me see here. So let me go back. And if we look at this next one, okay, here are some of the answers right here that you guys can see. If we were talking about hydrogen and oxygen, again, we know that hydrogen has a +1 charge, oxygen has a -2 charge, okay? Manganese, that's one of those odd ones. It has a +7 charge in this particular case, okay? It has a +7 charge, but let's say you did not know that. Here's what you can do, okay? I'm gonna go do this one off to the side over here. For number 3, I'm gonna use this space over here on the left-hand side to answer that question, okay? For KMNO4. All right, so let's say that we have KMNO4, and we're trying to figure out the oxidation number for manganese. Well, we know that potassium has a +1 charge. We know that oxygen has a -2 charge, okay? We're going to set this to equal to 0, all right? Set this equal to 0. Now, here's the thing, though. I'm going to color code. Let me put the manganese in a different color so you all can see that, okay? That's the one that we're looking for, in case you didn't know what manganese's charge was. So what you're going to do, you're going to say +1, so that's a +1, plus X, that's what you're looking for, minus, you have 4 oxygens times that -2, okay? And let me zoom in a little so you all can see that, equals to 0. So you've got 1 plus X, okay? So right here, and that should have been a positive because you're adding them all together. That 4 times that -2 gives you -8, and that's equal to 0. Well, 1 minus 8, of course, it's going to equal to -7, okay? But you've still got the X though right there, okay? This is still equal to 0. So you have the 1 minus the 8 here, that gives you -7, and your X is here. You're trying to move the 7 to the other side over here, and you end up with saying that X is equal to +7. So that's how we know the charge for manganese equaling to +7, okay? right here for manganese. Now, someone said, what about iron? Okay. So iron is one of those unique elements. And I know, again, we're looking at number 10, okay? Number 10, Fe2O3. So if we were to look at Fe2O3, okay, for instance, Fe2O3, and we wanted to find out, well, what is the charge on iron, okay? We know the charge on oxygen is -2. We're going to still set this equal to 0. So in other words, 2 times that X plus, you've got 3 of those oxygens times the charge for that oxygen equals to 0. So 2X minus 6 equals 0. Okay? So now you've got to add the 6 to both sides so that the 6's can go away. And you've got 2X equals to a positive 6. And divide that by 2 by both sides so that you can figure out what the X is going to be equal to. And 6 divided by 2, of course, is positive 3. So I know that the iron will have a positive 3 charge. Okay? Hey, Will, what do you want to know about electron affinity? That's not dealing with this lesson for today, but I will try my best to get to that question, maybe at a later date, or, maybe do a video response. Okay, so now, if you take a look, I'm going to zoom back out a little bit, okay? And what I'm going to do now, we're going to actually use this information here to go through some more examples, okay? We're going to use this information to go through some more examples. So let me clear the drawings here. And now let's move on to the next part. Now we're going to practice some more examples here, okay? Thank you, Des. Okay, Will, I got you. So if you were to try to assign the oxidation number, okay, let me zoom in a little bit so that you guys can see this right here. We're looking at example number 1, okay, right here, number 1. And they're saying, what is the oxidation number of chlorine in NaCl? So again, it's going to be based on what we've talked about before, okay, in terms of trying to establish the oxidation numbers, okay? So what I'm going to do now, I'm going to put an X over chlorine because that's the one that we're looking for. We know that sodium has a +1 charge. We're going to set this compound, and let me zoom in so y'all can see that, and set that to equal to 0, okay? So you're saying 1 plus X equals 0. Now remember, we're going to subtract 1 from both sides. And so your X is going to be equal to -1, okay? So chlorine's oxidation number is -1. Chlorine's oxidation number is -1. Let's look at the next one. This next one says, determine the oxidation number of sulfur, okay? So we're going to put an X above sulfur because that's what we're looking for. Hydrogen, we know the oxidation number for hydrogen is +1. The oxidation number for oxygen is -2. So what are we going to do? We're going to say 2, and I'll try to put it underneath here so y'all can see that. 2 times that +1 plus X plus 4 of those oxygens times -2. And we're going to set that equal to 0, okay? We're going to set that equal to 0. Now, I know this is very small, from what I'm writing here. So underneath that, I'm going to write it in a different color so you all can see the new answer, okay? So 2 times that +1, that is correct, Giselle. That is essentially correct. 2 times that +1 is 2 plus X plus, so you've got 4 times -2. So that's going to actually become -8, okay? So I'm going to erase that positive sign and put -8 right there, okay? And again, that's equal to 0. Now I'm going to keep going underneath here on this part just to keep the problem going, okay? So you've got 2 minus 8, that's equal to negative 6. You still got your x right here, okay? Whoops. You still have your x right here. And that's equal to 0. Well, guess what? We're going to add 6 to both sides. And so our x for sulfur is going to equal to a positive 6 charge. Okay? So the charge on sulfur is positive 6. Now, we already did the one right here for iron before. So I'm actually going to move down to one where you have a polyatomic ion. Okay? And you're having to do what? You're having to set that charge to equal to, or you're going to have the compound set to the negative 2 charge. So let me show you what we mean by that. Okay, so this one right here that I'm circling, I'm going to rewrite it over here in this space so that I can have some space to write everything out. Okay, so it was Cr2O7 with a negative 2 charge. That's the ion for chromates. Okay, so because we're looking for the oxidation number for chromium, okay, I'm going to put an X above that for chromium. So I'm going to say 2. Oh, but I'm sorry, before I even get to writing this part down. So for chromium, okay, it's X because you're looking for that. The oxidation number on oxygen is negative 2. So now what you're going to do, you're going to say, okay, 2 times X, okay, because you're looking for that one, minus 7 times negative 2 equals negative 2. Now, again, in case you're wondering, wait, what? Whatever the charge is here for your polyatomic ion, you set the compound to that number. Remember, the other ones that we did over here that did not have ionic charges assigned to them, they were set to 0. But for polyatomic ions, such as this one, you set it equal to whatever the charge is. So now if we go ahead and do, I'm sorry, it's plus 7. You know what I'm doing, Giselle? Thank you for that question. What I am doing, whenever I'm writing this out, I'm writing out the charge before I can write the number out. So yeah, thank you for that clarification. Thank you so much for that. Yes, that's plus. You're always adding the numbers, and whatever the charge is right there, you're gonna put the charge beside it. And that's I wanted to clarify that, but thank you. Yes. Thank you for catching that. So now what you're going to do, you're going to say, all right, 2x minus 14 equals negative 2. Well, we're going to add 14 to both sides so that we can get 2x by itself. And 2x equals, well, what's 14 minus 2? It is equal to 12. So when we divide 2 by both sides, x is equal to positive 6. So the charge on that chromate ion is positive 6. Okay, it is positive 6. Now, if we go through this next part right here, again, you can see the answers. And I just shared the answers here that we just did a few of these examples, okay? And here are your answers again, so that way you all can see them. Okay? Now, we're doing all of this because, again, in order to do electrochemistry, you've got to understand oxidation numbers, especially when we get into these compounds and having to write and balance redox equations, okay? Now, we won't have time to go through these examples right here. So what I am going to do is go through and show you guys another thing that you all would need to know, and that deals with electrochemical reactions when you have cathodes and anodes, okay? And I'm going to show you all some easy tips and tricks to help you remember that as well. So let me go ahead and stop the share for this part, okay? So that I can actually show you all the next part of what you have to do, okay? So I'm going to actually move us over to now, I think this is the one, let me see right here. Yes. And actually, it's the other one. Let me see. Oh, yeah. Let me share a different one. Yes, this screen right here. Yes. All right. So here are some things you got to know also when it comes to oxidation rules and remembering how to do electrochemistry formulas. And also, when you're dealing with cathodes and anodes, okay, there are some key things I want you all to know. All right. So anodes, that's where your oxidation is occurring, where you're losing electrons. Okay. So when you're in a galvanic cell, it is also the site where electrons are produced, okay, and from where they flow through the external circuit to the cathode. It has a negative charge because it is the source of electrons. Now, when you get to cathodes, on the other hand, so let me highlight that definition so you all can see that, okay? So anodes, this is this. Oxidations where you're losing electrons. Cathodes, on the other hand, is reduction. That's where you're gaining electrons, okay? And that is because it has a positive charge and it consumes electrons, okay? So now here's what I want you all to remember or recall, even from this particular part of the lesson. If you know what happens when you are rearranging your cells and you're having to calculate the standard cell potential for between zinc and copper, we have to go back to the rule of knowing which one of these is going to be the anode and which one of these is going to be the cathode. And it's based on their location on the periodic table. I wish I could insert a periodic table right here. Well, I can. I actually can. Because I think you all need to see what happens in terms of where they're located. Okay, so let me go ahead and insert a periodic table here. Okay, because I think you guys need to know where they are, and it's going to take a lot for me to just go back and forth. Leah, she's thinking, can I take her exam for her? Yeah. Y'all are funny. So if you take a look at the locations of these elements, okay, so I'll go back and reference these every so often. So we were looking at zinc and copper, okay, zinc and copper. So here's zinc, okay, and here's copper. They're next door to each other. The further right the element is, it would be classified as the cathode, okay? So if it's right, it's the cathode. The further right it is. Right, Giselle. The further right you go, that would be considered the cathode. Okay. So, and because that's the cathode, you would have to write it out like this. So let me go ahead and show you all and demonstrate for you guys right here. Okay. So that way you all will know. Zinc, you have zinc, which has a +2 charge. Oh, can't see that part. Sorry, guys. And then you have copper, okay, with the +2 charge as well. But because zinc is further right, okay, that's going to be the cathode. And because it is the cathode, I'm going to show you all how to write it out in that terms, okay, in terms of arrangement. Now, here's the other thing too. Because it is the cathode, you would write it out like this. Zinc with the +2 charge plus 2 electrons is going to yield you that zinc ion. Oops, sorry. Copper, it is the anode. So copper being the anode, you would write it out as copper yielding copper with the +2 charge plus 2 electrons, okay? Now, when you write out the cell, okay, formula for this to determine the cell potential, the formula is the cathode minus the anode, okay? So the cat minus the anode, okay? So the E cell, okay, is equal to, and the number that was assigned for zinc was negative 0.76 volts minus, Alejandra, I don't do organic chemistry, sweetie. I'm sorry. I don't. Minus copper's charge, which is a positive 0.34 volts, okay? So all you're going to do is basically say the E cell is equal to, and let's plug this in the calculator together so you all can see that. So I've got 0.76 with a negative charge plus, oops, hold on, negative 0.76 minus a positive 30.34. That's going to give you negative 1.1, okay? So the E cell is equal to negative 1.10, okay? And that's volts right there, okay? Okay, hello? Is it Deja? All right, how do you know which one's a cathode and which one's the anode? Okay, so again, the difference is, all right, let me pull the periodic table up so you can see that, okay? The further right it is on the periodic table, the more electronegative it is, and the more electronegative that it is, the more chance of it being the cathode. So the farther right you are, it is going to be the cathode. So if I were comparing, let's say, calcium to, let's say, iron, well, iron in this case will be the cathode, okay? And the anode will be calcium, okay? So the farther right you are, that's because of the electronegativity. Yes, thank you, Alexis. Oil rigs. Oil rigs. Oxidation is lost, reduction is gaining. Yes. And oxidation is the anode, okay? And the reduction is the cathode. Red cat. Yes, I've heard all kinds of mnemonics to help students remember this. Yes. Yes, yes, yes. I love when y'all come in and help out, help each other out. Alexis is also a chemistry professor too. If you all didn't know, yes, Alexis Rivera is also a chemistry professor. Now, if you think about all of these different examples here, okay, I'm going to show you all one that we're going to do, okay, as well, because I want to keep these examples going so that you guys can see this. So I'll refer back and forth to this particular periodic table. So matter of fact, I may copy this. Let me see if I can copy it over to my next screen. So I'm going to share this next example right here. Oh, it disappeared. Okay, so right here, whoops, not that one. Let me go back and get the other periodic table, okay, because it went away. Let's see if I can grab that again. There we go. All right, so look at silver. Let's find silver, okay? And then let's find iron. So here's silver right here. And then here is iron. Okay. Now, if you take a look, silver is further right, okay? Silver is further right. And because silver is further right, we know, based on what we just talked about, silver is going to be the cathode, okay? So in other words, the more positive the number is, or the higher the number is, it is going to be the cathode, okay? And the further right that it is, the more negative or the lower the number, it's going to be the anode, okay? So in this particular case, though, you also have to consider the location of your elements. So when we go to the right, we know that fluorine is the most electronegative element. Yes, we know that. Okay. Fluorine is the most electronegative element. So because we know that, that also helps guide us in terms of the farther right you go, the more electronegative it is, the more attractive force that it is. Okay, that's something else that you can kind of think of. I know, right, Jataro? I'm sorry. So now we know that silver is the cathode and the anode is iron. Okay. So now what are we going to do? Well, we're going to write it out, the way we know how. All right. Because this is the cathode, we're going to write it as such. We're going to say silver, okay, with the plus charge plus that negative electron yields silver. And then for iron, we're going to say iron. All right, iron yields. Oh, y'all couldn't see that. Sorry, y'all. Iron yields that iron with the +2 charge +2 electrons, okay? So if your teachers tell you guys to write this out, the cathode and the anode, this is what you would need to do, okay? Now, let me also write out what is the electrocell potential for this reaction here. So the cell, again, the formula is your cathode, okay, minus your anode. So in this particular case right here, we're going to put the cathode value, which is positive 0.80 volts, minus, and then parentheses, iron's voltage is negative 0.44. Okay? Now, when you have two negatives, it essentially becomes a positive, okay? It essentially becomes a positive. But again, because I know you all want to see this in action, here we go. 0.80 minus 0.44 negative, and you get positive 1.24, okay? Positive 1.24 volts. All right. Now, we're going to do a few more examples. I got 3 more examples, and I'm going to leave that periodic table up there so that we can use that for this next question right here, okay? So we've got magnesium and we have nickel. So let's figure out what we're going to do. Which one is the cathode and which one is the anode? All right. So take a look. Okay. Let's take a look. We're dealing with magnesium and nickel. Okay. Even though we see the charge, magnesium has a +2 charge. Nickel has a +2 charge also. They have the same charge, but are they the same? So let's figure this out. Again, where is nickel? Nickel, where are you located? You're right there. Okay, so there's nickel. And then magnesium is right here. Okay, so B solo cup is saying it's nickel the cathode. What do y'all think? Is nickel the cathode? You are right. Nickel is the cathode. So what are we going to do? Let's get this math in. Again, I like writing everything out because you never know what your teachers will request of you, okay? What they're going to have you all do. Magnesium, of course, is the anode, okay? Remember, because nickel is the cathode, we're going to write nickel like this. Nickel with the +2 charge plus those 2 electrons gives you nickel. And then the anode is magnesium, giving you magnesium with a +2 charge plus 2 electrons, okay? Now, again, we got to write, yes, you can think of it that way. Yes, be slow, club. Yes. You've got the cell, to find your cell potential, is, again, it's going to be the cathode Thank you, Axel. Appreciate that. Cat minus the anoid, okay? I'm just abbreviating so I can write everything out. So you've got the E cell, that's equal to negative 0.23 volts minus, and then in parentheses, negative 2.37 volts. Now, what do we need to do? We need to know that those two negatives are going to become positive, okay? So again, if you wanted to rewrite everything out, you could do that. Just know that when you have two negative signs, you're basically adding those together. Okay, so again, you're going to say 0.23, that's a negative 0.23 plus 2.37, and you get positive 2.14. Okay, so the electrocell here is positive 2.14 volts. Make sure you put those units there. Teachers take off points when those units aren't there. All right. We got two more examples. All right. Let's go to the next one. The next example. Again, we're going to go back and refer to our periodic table in case you guys forget certain things. Because again, you got this one right here where you have lead 2 and cadmium 2, okay? Lead and cadmium both have a positive 2 charge. Let me zoom in so y'all can see that. Let's find their location on the periodic table, okay? I'm all about that periodic table life, okay? This periodic table is like, it's golden, okay? It's like the Bible, for those of y'all that, go by it, okay? It's like the chemist's Bible. So we were dealing with cadmium and lead. So here's cadmium right here that I'm circling right here. And then here's lead. All right, so in this particular case, okay, which one of those is going to be the cathode? And which one's going to be the anode? I know, right? Oh, electrochemistry is the bane of my existence. All right, so because lead is farther right, that is your cathode, all right? Yes, user, you could say that as well. Yes. Whatever you need to do to remember that, yes. Yes, yes, yes. So now we're going to write that out again. Lead is the cathode, okay? And cadmium is the anode. And because we know that, okay, we're going to write them out in their formulas. And remember, I'm doing this because when we get into this part tomorrow with the electrochemistry and we're having to write out and balance oxidation and reduction reactions, this is going to come back to haunt you, okay? You're welcome. So what we're going to write out for lead, we're going to say Pb with the 2 plus charge plus 2 electrons gives us that Pb. And anode, well, it's Cd, gives us Cd with a plus 2 charge plus 2 electrons. You're just trying to balance them out, okay? Yes, cathode red gains electrons. That's right. So now for our E cell, okay? Again, I just always write the formula out in case we have students who forget it, okay? You're going to say the E cell is equal to the cat, which is the negative 0.13 volts minus, parentheses, negative 0.40 volts for cadmium. Remember, 2 minus signs is basically positive. Okay, so again, yes, I do. over Zoom. Yes, user, I do tutoring, private tutoring. Yes. And you can hit the link in my bio to get it, to get information about it. So you've got the negative 0.13 volts plus 0.40, okay? And you get positive 0.27 volts, okay? All right. And we got the last one to go, guys. The last one. Here we go. I say the best for last. Gold and copper, which, by the way, do y'all know that gold and copper, they're increased, not copper, gold and silver are increasing their value. If you want to buy metal, I ain't no financial guru, but what I do know as a chemist, and I follow, the stock market, gold and silver are trying to be neck and neck. Okay. FYI, go look it up. Go look it up. And the price of gold is increasing and silver is like, I'm coming there with you too. So when you take a look at gold and copper, let's see where gold and copper are on the periodic table. Gold has a positive 3 charge, copper has a positive 2. Okay, does that matter? Tomato, tomato? Maybe, maybe not. But let's look at their location though. Gold is right here at the very bottom of copper. Copper is on top. Now, if we remember when we first talked about this, we said electronegativity plays a role in what's going to be classified as being the cathode, okay? So in this particular case, gold is on the bottom. Normally, when you go down the groups, the electronegativity decreases. But in this case, for copper and gold, it actually increased. Having said that, because of that process, gold is going to be the cathode and copper is going to be the anode, okay? Because of that. So when we do this last problem right here, okay, I just told you gold is the cathode and copper is the anode. That means I'm going to write out gold with the 3 plus charge plus 3 electrons to give you gold. And then you've got your copper, okay, which gives you the plus 2 charge, plus those 2 electrons to balance it out. So now what we're going to do, we're going to take our E cell, okay, and we're going to say again the cat, okay, minus the anode, okay? So we're going to take our cat, which is positive 1.50 volts minus, you have a positive 0.34 volts. So in other words, this becomes positive 1.5 volts minus 0.34 volts. So you're basically subtracting those two numbers, okay? So positive 1.5 minus 0.34 gives us positive 1.16 volts. That is your E cell for this particular gold copper cell. All right, guys. So it's been lovely working with you all today. My time is up and I will be back tomorrow, same time, same place, 12 noon Eastern Standard Time. For those of you all that are not familiar with me, if this is your first time coming on my live, I go live Monday through Thursday, 12 noon Eastern Standard Time, 12 noon Eastern Standard Time, Monday through Thursday. Oh, you're welcome, Layla. I appreciate you. You have a great day as well. So you guys have a great afternoon or morning or day, whatever time it is for you. Make sure that if you all are upset about learning chemistry, take a breath. walk away, breathe in, breathe out, and come on back to it. Thank you, Dee Dee. Thank you. So yes, you guys do not have to let chemistry stress you, okay? You do not have to let chemistry stress you. I promise you, you don't.